All right, today we want to look at a very important question on the board, and it says an object of mass 20 kilograms slides down an inclined plane at an angle of 30 degrees to the horizontal. Find the coefficient of static friction. G is equal to 10 meters per second squared. All right, this question is a question under solid friction. It is a situation whereby a body of mass slides down an inclined plane. All right, let's represent this question on a diagram. We have a plane inclined at an angle 30 degrees to the horizontal. So we have a body on this plane, a body of mass. You know, the mass acts directly downwards towards the gravitational pull. So this is the direction of the weight. So we have mg here. Then along this plane, there is a force acting directly along this plane. That is, the component of this weight along this plane is given by mg sine theta. All right. Then this force in this direction, which is a component of this weight along this plane, is also equal to this other force. Remember, action and reaction are equal and opposite. So the force acting towards this direction is equal to the force acting towards the other direction. So let's use F to represent this other force. Then from this point here, we have a force acting directly perpendicular to this plane. This force here is the normal reaction R. The normal reaction is always perpendicular to the plane. And then we have the force acting in that directly opposite to that normal reaction. And then this force is given by mg cos theta. Mg cos theta. That is the component of this weight along this direction is mg cos theta. All right. So with this, we have five forces acting on this body. This force here, the frictional force, then this other one here along this plane in this direction. Then we have this normal reaction directly perpendicular to the plane. Then we have the one that is directly opposite to the normal reaction. Then we have the weight or the product of mass and acceleration due to gravity. This one is acting directly towards the Earth's surface, towards the force of gravitational pull. All right, so using the laws of friction, you know that the force, the frictional force, is directly proportional to the normal reaction. Frictional force is directly proportional to the normal reaction. And then frictional force F is equal to the coefficient of static friction multiplied by the normal reaction. This coefficient of static friction is the constant of proportionality. Remember that this is variation, all right? And then we have introduced the constant of this proportionality. It's a direct variation, so this is the constant. Then, making the coefficient of static friction the subject, then we have that mu is equal to F over R. F over R. So from this diagram, our F is equal to remember that this is F and it is equal to this part, all right? So which is mg sine theta, then divided by our R. Look at the value of our R. That is the normal reaction, a force that is directly perpendicular to this plane. And you know that this reaction is equal to this other component here. So that reaction is equal to mg cos theta, all right? Okay, so simplifying further, we have that our mu, which is the coefficient of static friction, is equal to, of course, this mg here will cancel this mg here, and what we have left is sine theta over cos theta. Sine theta over cos theta from your trigonometry is equal to tan theta, all right? So our coefficient of static friction is equal to tan theta in this case is what? Is 30 degrees. 30 degrees, that's the angle of inclination of the plane to the horizontal. So tan 30 is equal to 0.577, which is approximately equal to 0.6. All right, that is when you round up to the near, that is to one decimal place, you have 0.6. So this does not have a unit. It's one of the dimensionless quantities we have in physics. The coefficient of static friction does not have a unit. So this is the final answer. I believe that this one helps. Thank you very much, and bye-bye.